Hello, everybody. Welcome to this online event organized by the OpenStack Europe community. And I'm going to be your host of today's meetup. My name is Nils Magnus. I'm Community Outreach Manager at the Open Telecom Cloud, which is run and operated by T-Systems. I'm going to be your host today and lead you through the different sessions. So let me give you a short intro about our community here. So OpenStack Europe was an initiative we started more than a year ago to run an infrequent number of sessions like this for several topics around the OpenStack subject, some directly related, some indirectly. So we want to provide a little bit technical input. We want to provide some hands-on experience that everybody can use in his daily life. And we also want to see some insights in services or latest updates to that. So we are now a global community of about 320 members right now. And its purpose is to do some knowledge sharing and exchanging best practices in the general field of system engineering, system administration, but also development and DevOps around public, OpenStack-based clouds, such as, but not limited to, the Open Telecom Cloud. So the whole event is made possible also with thanks to the collaboration with some of our partners. So especially I would like to thank our local hosts who also take care of this streaming session. I think, yeah, here's some info, a slide about them. The Deutsche Telekom IT Solutions in Hungary, also proud winners of Career Prize in the Hungarian market. They support us to a great deal to make this all happen and to provide the streaming facilities for that. Thank you so much for that. Then I would also like to introduce the so-called Clouders Club. That's a channel, a YouTube channel, where we also place the recording of this session into. And of course, I want to thank all of our speakers for today. I want to thank everybody who is working and supporting us in the background, at the video and the preparation and the speaker management and so on and so on. So thanks to all go out to all of you. And last but not least, there's a special occasion today since OpenStack just turned 15. And for that, let me just see what I've prepared here. I hope we can see this a little bit. Let me just check. Here we go. We have actually a birthday cake, which we are going to eat after the call, after we have heard about all the technical sessions, as some birthday celebration party. Yeah, it's already 15 years, so quite some time was passing since then. I don't know who remembers back in 2010, the inauguration, when I think it was some folks of NASA at Rex Space who joined forces, or who have already joined forces and then released their code, which would become one of the biggest and most important open source projects that has ever been created by the global community. And well, it's a success story, especially if it comes to sovereign cloud computing. So something where you can actually look inside the code and gain some deep insights on the inner working, which is a major difference to the typical hyperscalers, where the actual inner workings of the cloud is hidden by the providers. So if you really are aware of looking for these freedoms, then OpenStack is the right solution for you. So just to drop a few numbers, so at the moment, more than 45 million compute cores are generally in production globally. This is an estimation of the foundation. And this is about 3 or 5 times as many as we've been about 5 or 6 years ago, which is quite robust growth and some widespread adoption. It is run in several data centers. So alone here at Deutsche Telekom, we run more than 9 production data centers in 3 different regions. In the future, maybe even a 4th region will be added to the global network and so on. But let's not bore yourself with all those numbers and turn a little bit to today's agenda. We have 3 slightly different talks today and topics, but everything is about how to make things faster, smarter, safer, or something like that in the cloud. So we have 3 incredible speakers lined up, and let's see what those expectations and perspectives that our 3 speakers bring to this show today. We will start with Artem. We worked together quite for some time, and I'm very happy that you could make it for today and let us know a little bit about your latest project that involves rewriting some very central and very important component in the OpenStack stack, and that is the IAM functionality, which is known as Keystone. And Artem has started to rewrite some of those components in Rust, so not in Python. And well, I'm pretty sure that we can get some latest updates in performance numbers, which can be quite interesting and will spark one or the other discussion in future technical sessions of OpenStack for sure. I'm pretty convinced of that. Second will be Thorsten Schlump, who is going to show something very, very useful. That is how to spin up some infrastructure, for example, for Kubernetes cluster, just in minutes, with Terraform. I mean, it's a tool that is very widespread and more or less deemed go-to-market component for any cloud. So a cloud without a Terraform, a provider, cannot be really considered a real cloud, I think. And Thorsten will show us how this can work specifically on the Open Telecom Cloud provider for the Open Telecom Cloud. And last but not least, there's Attila Tokai, who is presenting a little bit about how to deal with storage. And storage in cloud is often connected with object store. The object store project has, of course, also an API and some libraries, and those libraries provide connectors to the Python programming language, something that is pretty widespread in the development and the DevOps community. So Attila will show us some interesting sparking ideas on how to use that, since there's more in it than it appears at first sight. Yeah, is there something else that I should get you prepared about? Let me think. I think I have most of the stuff conveyed here. Let me just go through some technical notes that I have. So before we start the first presentation, I have some technical information for you as it's being recorded. We talked about this, so keep in mind that you are recorded then during the Q&A sessions, which we run after each talk. Yeah, if you have any questions, please use the chat for it if you want, or just take down your question, and we can also turn on your audio when the session itself is finished. All right, I hope you enjoyed the short warm-up, and then we don't waste any more time and just hit the main event. And I'd like to add him to the stage and let's say the stage is yours. Let us know how to speed up things with Rust, Tim.
Thank you very much, Nils. You see my screen, right?
Excellent.
Perfect. Okay, so let me just reintroduce myself. My name is Artem. I was working with Nils for quite a long time. It was actually 6 years, Nils.
Oh.
It was really a very pleasant time. Since recently I'm working at SysEleven. This is another German-based company which is also doing public cloud, which is also offering OpenStack. So I'm just sticking to OpenStack. I'm a delivery manager there, but more than that, I'm actually at the moment project team lead for Keystone. That is exactly why I would be talking about that. I'm also project team lead for OpenStack SDK CLI, taking care about all the client tooling that users should be using for communicating with OpenStack. And I would be talking about necessities and possibilities that what can be achieved if we would rewrite Keystone in Rust. Maybe only certain components, certain pieces, but it's actually more about that. So quickly, agenda. First, I would start describing what I was working on. So just to explain why I came to that idea. It's not that I was bored and decided to rewrite everything yet again. There were real reasons. Then we are going to have a relatively brief look on how authentication is working in Keystone, because it is basically a central component and central part of the Keystone, taking care about authentication authorization. Next, we are going to look exactly on the things about introducing Rust here, followed by having some looks at the performance and the way forward. So what can be achieved with that. So what I was working on in the last couple of years, I was quite a lot of time investing into different aspects of identity federation. I was working within 4 different cloud providers, and all of them were having certain aspects and attempts to federate identity from external IDPs. Like, imagine you have Okta, imagine you have your Google, you have your LDAP, whatsoever, and you would like to integrate just users into OpenStack, or allow people from your company to use your corporate identity provider to log in into OpenStack, to consume OpenStack resources. I was trying to solve some problems that basically the whole federation in Keystone is managed by proxies, or basically by HTTP proxies that need to be deployed in front of Keystone, which is like Apache, Nginx, or anything else. And typically the whole federation is implemented or delegated, I would rather say delegated, but to mod also IDC or mod Shibboleth if you are talking about SAML implementation. So this functionality is not implemented directly in Keystone. That leads to actually quite big limitations on the functionality, on possibilities that can be achieved. And since you delegate the federation work to external software, normal outcome is that any modification would require restart either of Keystone or of those HTTP proxy servers. That leads to downtime and is simply not the way to do. Also, there is, like, if you are into the federation, maybe abbreviation scheme is not unknown to you. This is a system cross-domain identity management, which is basically something that is used on top of OIDC or OAuth to synchronize identities between different systems, between identity provider and service provider. And again, this is not implemented in Keystone, which is leading to certain issues. I also tried to implement possibility to exchange JWT for an OpenStack token, which is something that I would be talking later a little bit more in detail. But this can be something where if you want, for example, to access your cloud resources while running GitHub Actions or GitLab CI, or any other trusted system, and you would like that your workload is able to access OpenStack in an automated way without hard coding passwords somewhere. That is basically exactly the thing that deals with that. And then quite usual problem, lack of fine granular access control, which is basically OpenStack is relying on RBAC, role-based access control. And it has a typical problem of role explosion. Once you try to address, to implement more fine granular roles, you end up in different scenarios, and you have literally just hundreds of different roles, and it's impossible to maintain it reasonably. Yeah, well, it's too much to explain. Let's have a look on certain authentication flows, or actually how the authentication in OpenStack is being implemented. So you see here the workflow diagram, and first user is sending to Keystone request for authentication and authorization. If most likely you don't know really the technical details there, but it's actually a single request that combines authentication and authorization information. So yeah, the user is sending a single request to Keystone. Keystone is verifying user identity, is verifying also authorization, whether the user is allowed to do what he actually wants. Or on the other side, it basically checks what user can be doing and returns back to the user the token with fixed authorization. Fixed here means that actually your token is valid only for the scope that you have requested. You cannot go to Keystone first and ask for token for project A and then work for the project B. This is impossible without actually rescoping. So this is really a very important thing to remember and to understand. Once Keystone returned the token to the user, all the further communication between user and services would be done using this token. So pretty much in every API request, there would be additional header xauth token set with the Fernet token itself. And the service, what is doing actually for every single request, it goes back to the Keystone and validates and requests the validation of the token that user presented. And there are a couple of important things that are happening at that stage. So first thing is what Keystone is doing is verifying, is this at all, or basically what the service is doing, is this really a valid authentication information? So is the user just faking data, or is it something that we can trust to? Second thing, what is being validated is that whether the token has been revoked or not. So whether the token has expired, maybe, or was directly revoked. And last but not least, it is ensuring that user is allowed to do what he actually wants to do. So imagine you are sending the request for creating server, for provisioning VM, and so you received your authentication from Keystone, you send this request to Nova. Nova goes back to Keystone, and Keystone says, well, the user doesn't have the role that is required to provision the server. So this API request would be rejected by Nova. But in the positive case, when everything is fine, then the service would return the response back to the user. So this is basically really very stripped down workflow explanation. In reality, it is much more complex. There are multiple levels of caching. The authentication on itself is also not that easy. It is literally just really very, very simplified flow. Let's have a look on which authentication methods Keystone is currently supporting. So you can authenticate yourself with username password. In addition to that, maybe there is necessity to also use MFA device. You can also authenticate yourself, or basically it's more designed for certain applications where you can use so-called application credentials, where basically for the user, you can, in the scope of the user, you can create multiple application credentials, and those would be static credentials, maybe also with a certain expiration date, with some limited roles that you would be hard coding somewhere in your workflows, maybe also. Most likely that is exactly what you are using for your Terraform. And yeah, some different scenarios where, for example, also Kubernetes cloud provider is mostly being deployed with application credentials. And then we have a token, so you can authenticate yourself using the token of the Keystone. That is typically used in the context of rescoping, where first you go to Keystone, you ask for one scope, And then in the process of your work, you figure out necessity to actually rescope your token. And instead of simply repeating your username password, you can present your token, which should be still valid, saying also, please give me now the token valid for different scope. Or maybe also you want to extend the lifetime of the token that you have already. And then a couple of additional more esoterical, I would say, authentication methods like OIDC, external authentication, which is where your HTTP proxy in front of Keystone is authenticating you. Maybe it's basic auth, maybe it's TLS-based authentication, maybe it's something else. But anyway, in that particular case, the authentication itself is being done on the web server or on the proxy side. And Keystone is then trying to map this authentication down to authorization. And corresponding to that will grant you then token. And then there are a couple of other possibilities like OAuth 1. There is actually also OAuth 2, but it's a little bit tricky. And anyway, OIDC is built on top of OAuth 2. So yeah, there are some interesting things about that. SAML2 and TLS certificates, those are currently authentication methods that are supported by Keystone or Keystone plus some additional software, but there is nothing more. We need again to most likely to differentiate, to have a proper differentiation between authentication and authorization. Authentication is saying who I am, who am I actually, yeah, right. So you are just like, imagine you are showing your passport to Keystone and it doesn't really check what you can do. It only checks that you are exactly who you are, who you claim to be. So username, password, application credentials, those are part of authentication. Authorization is, however, on the different side, is representing whether the user is allowed to do something. And when you request authorization from Keystone, you say, please authorize me, please give me a token valid for a certain project or domain, or maybe a system. That is exactly where you say, I would like to work with that target, in the scope of that target. And the Keystone grant returns you token, which is strictly bound to that particular requested scope, only if you have any permissions there. So basically the token will contain information about the project, domain, or system that you requested, and it will also contain list of roles that you have on that particular target. So again, key important warning, the token is bound to a requested scope. You can't authenticate for one project and then try to use this token for a different project. This doesn't work. Every service is actually strictly enforcing that scope information is present in the request, in the token, and even more that certain parts of URLs for the API are basically looking much easier without that scope information. So basically the scope information together with the URL of the API request gives you final address of the resource. So with all of that, Keystone library for Rust. Authentication and authorization themselves are pretty complex items and concepts. You should not say that, you can't say I'm only authenticating with username, password, and everything is great. If you go deeper into those concepts, things are becoming more and more complex. And once you land in the OIDC, in the OpenID Connect, things are becoming incredibly complex. Amount of good Python libraries for OIDC and scheme support is actually for the Python. Yeah, Python is very rare, and those are mostly even unmaintained. I was exploring a couple of possibilities when trying to add additional functionality to Keystone and found out that, well, with Python things are not looking really very promising. And then I also figured out that building a standalone component, something like a Keystone extension or extension to Keystone, would offer you the best flexibility, because I have experienced that a lot of CSPs running not the latest version of OpenStack. So they all on certain, maybe 2 years old versions of OpenStack. Some of them are even 5 years old versions, and so on. So the variety here is really huge. So what I mean here is that if we would start adding new functionality directly into Keystone, majority of cloud providers would not be having possibility to actually start using that without upgrading to the latest version, which is really not what you would like to achieve. But instead, if you try to go into the concept of something similar to microservices, then there would be possibility to deploy the new application together with normal Keystone and start offering new functionality to your users. Next thing, that there is already SDK, CLI, and TUI for OpenStack written in Rust, and those are really very useful already. Those are also quite powerful, and those are generated at the moment from OpenAPI's specification, basically really automatically without any human intervention. And it would be also really very easy to use that SDK, at least in case where proxying, some sort of proxying to native Keystone functionality would be required from that additional application that we are going to build. But yeah, anyway, what I have figured out is that building a new application is actually becoming necessary. It's pretty much impossible to add additional functionality into Keystone in the current form. So assuming that a certain sort of library is necessary, there would be need to actually grant a token. So that from using that library, you would need to allow user to authenticate or for Keystone to issue a token. And actually that aspect only is already touching nearly every single angle of Keystone functionality, where it needs to deal with users, with projects, domains, roles, assignments. It needs to also deal with Fairnet tokens. Basically, yeah, direct access to database is simply unavoidable because majority of that information is directly in the database. So if we would just proxy all the API requests, we would add additional overhead and will not get any performance improvement here. And the tokens in Keystone are actually Fairnet, which is also type of asymmetric encryption. Yeah, and underneath the Fairnet, there is actually also a message pack. So the token itself is relatively complex thing. It's not simply encrypt, decrypt. You need to prepare the payload really properly. And once we have the library, actually adding an API functionality on top of that is nothing complex. What the API is actually doing is it needs to validate the token that user presented. You would need to check the policy, whether user is allowed to do certain thing that he is actually trying to do or not. And the policy is currently not implemented, it's a work in progress. But still, I mean, technically, that the API also need to take care of that. It needs to convert the API request that it received from the user to certain backend structure of the request, perform the operation, and convert the response back to the API representation, and send it back to the user. And the final statement here says basically that OIDC authentication is not trivial. I mean here that adding API to the library is easy, but adding OIDC authentication is by far not easy. So OIDC is much more than simply a CRUD operation. And those are quite complex flows. Hopefully we'll have enough time to have a look on that. Now a little bit on the performance. So password hashing is slow, and is slow on purpose. And it's actually must be slow. You can't really say that password hashing can be implemented faster, because if that would be the case, then actually the protection using passwords would make absolutely no sense, and hackers would be able to brute force. So if your cloud is responding, is authenticating you when you are using password for authentication in less than 200 milliseconds, then the cloud is cheating on your security. So that's more or less fact. And what you see here would be a simple Python script benchmark for how Keystone is actually trying to decrypt the token. You see here at the bottom, there is just invocation of the token validation. So it's reproducing, and it's incredibly simple. And now the numbers, what we see. So I was actually comparing performance of that particular token handling with Python and in Rust, and basically on Linux and on Mac, just to see how the numbers are looking like. And you see that basically for using Python on Linux, the mean time for the decryption would be 200 microseconds. On Mac, it would be 77 microseconds, basically absolutely the same script, just invoked on different platforms, and you have already absolutely such a huge difference in numbers. And after re-implementing that in Rust, you see that those numbers are actually going dramatically, literally, really incredibly dramatically down. So it goes from 200 microseconds down to 9 microseconds on Linux platform, and from 77 down to 3 microseconds on Mac. We here basically, so to say, a disclaimer that you should not simply compare Mac and Linux, basically numbers varying between platforms really heavily. This is because certain processor manufacturers are doing a lot of optimizations, which are maybe helping in some case, in one case, but not in the other case. In the next step, I tried to actually implement a couple of use cases. So we are going to look at listing users, and that is done with Python, basically with Python Keystone, with current Keystone. So it's like a sandbox checkout of the Keystone, deployed locally on your laptop, and those are the numbers that you will get. So on a relatively, I wouldn't say old, I wouldn't say new laptop, I think it was Intel i7 device from something like 4 or 5 years ago. So it's not the latest, but it's also not the worst device. And we see here that average response time for listing users would be laying at 600 milliseconds, which is quite a lot, I would say, for me personally. It doesn't really matter how many users you have there. It's the time is relatively static. And the important thing that we see here is requests per second, basically that a single process of Keystone would be able to handle something like 13 requests per second. Re-implementing this in Rust brings numbers down or up depending on which number you're looking at. So if you would be looking to the average latency, now it's, so here we had 600 milliseconds, in Rust we have 7 milliseconds. And the throughput is actually increased to nearly 1,000 requests per second. And this is, again, just basically a normal laptop, not tuned actually for those workloads. And still here we have quite an impressive increase in throughput in the Keystone. I went another.
Just a short reminder. Yeah. So we are eating already slightly into the Q&A time budget. So just to let you know, a few more minutes is okay.
Okay, then I read the script wrongly. Okay, anyway, it's quite short then. On the 32 core, basically something like a server. It's not really a server that you are placing into rack in your data center, but it's still a server-based hardware. So the Python. With Python, the average latency is above 100 milliseconds. It's actually 170 milliseconds, and requests per second, you are able to get nearly 200 requests per second. Again, using the Python, then the native Keystone. Re-implementing that in Rust, you will see that average latency now around 12 milliseconds. So it just, well, it's actually much better compared to Python, and we are able to get actually nearly 2,500 of requests per second, so throughput from a single process. That is compared to the Python, to the Python Keystone, which is running really behind the proxy server with load balancer, so there are more than a single process running. And here in Rust, we have just a single process that is capable of delivering or serving 2,500 of requests per second. Now, a really very simple performance improvement of really in different steps. So first, you see the numbers of using Python OpenStack client with Python Keystone. And again, we are doing the user list operation. So here we see that the average time is still laying somewhere around 600 milliseconds. And so in the step of replacing Python OpenStack client with Rust OpenStack client, we are able to get already here 6-time performance improvement. So it goes down to 100 milliseconds in average. And if we then replace Python Keystone with Rust Keystone, we are bringing this down to 15 milliseconds. So overall, in the single use case of just listing users, we can get a 40-time improvement if we would switch to Rust. And this is, again, even without doing much optimizations. Okay, I'm slowly coming to the end. So this is more or less a diagram that we can skip, but it's actually in the Rust implementation, I have implemented the possibility to authenticate or authorize using security device. Security keys, like imagine a YubiKey or passkeys. This is more or less terminology that is used nowadays. So with the new Keystone, it would be possible to authenticate using not username password, but using security keys. OIDC authentication is actually much more complex. You may recognize here it's actually incredibly complex process. Every single step looks to be very easy, but in total to implement properly OIDC authentication, you would need to really have lots and lots and lots of steps, and actually there are so many variants of OIDC. There are like at least 6 different flows, and every flow is having additional configurations that can be done. So implementing OIDC properly is pretty complex. But anyway, this is what I'm working on, implementing this in the Rust Keystone. And yeah, finally, the roadmap for the project. So again, this is at the moment way beyond the proof of concept. This is already in a very good stage, but it cannot be used as a drop-in replacement for Keystone. So idea is to continue developing it, continue adding new functionality, and ensure that operators would be able to deploy this really as an additional component and maybe do some load balance, not load balancing, but proxying on the API gateway just to pass those additional API requests for additional functionality on the Rust component, while the normal API request will still be served by normal Keystone. Take care of that advanced authentication flows, like let users authenticate with their external IDPs, implement scheme, implement also possibility to exchange JWT, and that is again, just a reminder, you are having a GitHub workflow, and you would like that this workflow automatically gets the token for your OpenStack and is able to use it so that you don't need to hard code passwords anywhere. Security key, as I said, also, yeah. Then the goal is actually to let this new component overtake authentication and token validation from the Keystone so that you immediately get performance improvement for pretty much for every single API request. Because as I said at the very beginning, every service is going back to Keystone for validating token. So if you have a performance improvement here, factor 5, for example, for every single API call for the token validation, it's something that your users would immediately start seeing. And yeah, closing of functional gaps means adding new functionality. Yeah, that's basically it from me. You can see here links to the projects. First link is re-implementation of Keystone in Rust. The second is implementing SDK CLI and TUI in Rust, which altogether gives you, as I have shown in a simple case, performance improvement factor 40. But depending on the use case, there are literally like factor 100 is easily achievable. That's it from me. I'm open now for questions.
Thank you very much for the great insight, everything. So if there is anybody asking a question right now, I mean, I have plenty of them. Maybe I start. So the numbers that you have presented were indeed dramatic. So if I would want to benefit from those performance improvements in a production environment or in a semi-production environment, then I would have to implement on a proxy level in front of the Keystone functionality some kind of a switch, or what would you recommend for that?
Yes, at the very beginning, this is exactly the intention, because if you use federation, or anyway, most likely you have already Keystone running behind the proxy, which is doing some load balancing, which is maybe an API gateway. So the only thing here, you would be saying that certain API calls going to the Rust implementation, certain are going to the normal Keystone. And that was also one of the reasons why I'm trying to add new functionality really with brand new APIs. So I do not want to simply intercept existing API and start modifying it. I would like, if it's adding a new functionality, then it must be an additional API call that you would be able to route on your proxy properly. But there is also a possibility to implement normal full proxying from the Rust also to Python. So basically where Rust implementation can become something like a proxy server load balancer that would either serve the request itself or pass the request further down the chain to the Python keystone. This is not implemented at all, but still is a possibility.
Okay. And how did you implement that?
At the moment, I'm just running two keystones. Well, one with Python, one in Rust, and I'm just testing or sending. I'm having actually two different Cloud YAML connections. One is pointing to one keystone, one to another one, and this way. But I just know which functionality is implemented where. Ideally, of course, well, ideally, I'm not running public cloud at home. So that is why the problem for me is actually not so prominent.
Okay, I see. Good. And there's the question. I'm not sure if we have any other questions, not here on the chat so far. Anybody raising his hand? Not at the moment. Okay, then I think, wow, with that information, especially if it comes to speeding up some specific use cases, which especially expensive in terms of authentication and authorization. So running some huge setups of API calls that might actually profit from that. And what can the community do best to support you in your ongoing work here? Is there some need of extra resources, developer resources to work on that? Or is it more the testing, or is it more the general spreading of the word, or what would you say?
I would literally say the general spreading of the word, general interest and support. So maybe you have noticed the project is currently published on my GitHub repository. So idea is to make it official OpenStack project. So that is definitely the strategy. There are just a couple of things that from the technical committee point of view, Rust is at the moment not supported, not accepted as an official programming language. And therefore projects written in Rust cannot be listed as official projects. So it's like bureaucratic stuff. And my idea is here to get actually adoption by CSPs, by users, and once there is a big user base, then there is it's much easier to argument with the technical committee. On the other side, I'm definitely looking for any sort of support in regards of testing, in regards of bug reports, in regards to simply contributing, helping to implement necessary functionality, or maybe coming up with ideas or reports like statements. In our installation, we have an interesting use case that is currently not possible to be done with Keystone. So that is exactly also the place where this functionality can be implemented here. So yeah, that would be the biggest possible support.
So in the next meeting is probably at the next PTG in Paris, at next upcoming OpenStack Summit, Open Infra Summit, however it's called. Or are there other events planned for that?
I'm going to talk during Summit on that topic for sure. The PTG is going to be not at the same time with Summit. I haven't seen the schedule yet. When the
It's
PTG
a week before or after, right?
I think it should be after. Maybe before. That doesn't really matter. Those are not co-hosted.
Okay.
So we were discussing that already during the last PTG, and generally Keystone team supports that really heavily.
Okay, that's good to hear. All right.
So that's the future of Keystone, so to say.
All right. So thank you very much for the insightful presentation.
Thank you.
And with that, I think we can move on. Let me just take a look in my notes. Yeah, so next up is Thorsten Schlump. Thorsten, you're a technical consultant at the hybrid cloud team at T-Systems, right?
Yeah,
Can you get us some insights on your daily work and what you brought us for today in terms of Kubernetes and Terraform?
Yeah, as you said, I'm a technical consultant for the hybrid cloud, working in solution design department of T-Systems. And therefore, I have contact with the customer. And in most cases, the customer wants to see what we are offering to the customer. So my job is, one part of my job is showing the customer the cloud that we are offering to the customer. And what makes it easier if you can do the same thing with different clouds. So the customer said, I want to have this cloud or this cloud or this cloud. And we have demos prepared we can run in every cloud. We use the Terraform for this. And with this Terraform scripts, we can easily adapt by simply removing the publisher and adjusting the resources to comply to the new publishers. And then you're doing the same stuff for all the clouds. And if the customer wants, we can do it as a hybrid cloud. So combining the clouds with Terraform scripts. And this is what I have brought to you. So automating Kubernetes deployment with Terraform and Open Telecom Cloud. So using Terraform against the Open Telecom Cloud, so using the API of the Open Telecom Cloud with Terraform and automating things there. So the first question is, why does automation make sense? A nice question. I put this as a prompt in ChatGPT, and this is the outcome. And the outcome, we have some very, very interesting ones. Automation can perform tasks faster than humans, leading to increased productivity and efficiency in processes. So like our introduction, so code smarter, not harder. This is also included in the first one. And cost reduction by automating repetitive tasks. So doing the same thing multiple times, this can be easier with automation tasks. Automation ensures that tasks are performed with high accuracy and consistency. So doing the same thing every time with the same quality. And of course, data collection, you can analyze the output and so on. Everything is done with Terraform because you have the logs, and then you can analyze, is everything working fine? And of course, you get the output. And in the output, you can, for example, code the credentials for the first login and the IP address of your instances you created. So what is Terraform and what on earth is OpenTofu? So let's go to the past. Terraform by HashiCorp, this is the program they introduced. At some point, HashiCorp decided that one version is not fully open source anymore. And this was the version 1.5.5. And as you know, if there is a project starting at open source, getting to a closed source model, at this point, they get forked. And the first thing was, let's call us Open Terraform. Open Terraform was not a cool name because Terraform is the name of HashiCorp. So they called it OpenTF because all the files have a suffix called TF, which was also not fine for HashiCorp. And now they had a problem, find a word which has T and F in the right combination to match our project. So they called it OpenTofu. That's why it's called OpenTofu. Both are identical up to version 1.5.5. So the difference between Terraform and OpenTofu up to version 1.5.5 is 0. Since then, they developing in different ways. So Terraform has some points they optimize for OpenTofu, some other words, but they are still compatible. So if you are using only the API of version 1.5.5 of Terraform, you can use Terraform and OpenTofu in the same way. So you will see in my examples, I will switch between Terraform and OpenTofu, and you will see no issues because they use the same syntax, they use the same file layout, they use the same directories, and also they use the same publishers. Terraform in a nutshell. Terraform has 3 elements configuration language. So Terraform is a describing language. So you describe what you like to have. So for example, you describe some instances you want to put in the cloud. You describe the network to combine the interfaces, and you describe the database to be installed inside the virtual machines. So it's a describing language, and then Terraform will check what is there and what should be there and creates a delta what Terraform should doing. To doing this, you define resources. These are dynamic assets. These are assets that will be created or destroyed. So this is the dynamic part. Data sources are the static parts. For example, if you already have a security group defining what is allowed and what is not allowed, and you want to reuse it and don't want to create a new security group, you can define the security group as a data source and reference it later in the resource type of the instance. Last but not least, as I said, the provider. So in the default, Terraform only has the language Terraform, data sources and resources, but don't know what to do with any cloud. So you need a provider. And for the Telecom Cloud, there is an official publisher ready. You see, it's updated 4 days ago. So I think I don't have this version yet, but you see it's in development. And you can download it from the Git repository and use it in your programs. What must be done to define a publisher? So the first file you create in Terraform is the main Terraform file. In this file, normally you only have 2 entries. The first one is Terraform, where you define your provider which you are using. And in this case, I defined Open Telecom Cloud, and I currently defined I will use version 1.36.31. So this is the minimum version he should find. And at this location on my disk, he should find a version with this version or higher version. And I also said required version is greater or equal 1.545. So this is because, as I said, up to 1.545, everything is equal. So I define this API has to be used. The provider Open Telecom Cloud needs some credentials. And this is the most interesting part, where to get these credentials. So the Auful is easy. This is documented in the OTC documentation. Region and tenant name is all the Netherlands. And domain name you get from us if you get a tenant inside the OTC. To define an access key, you can simply go to your credentials in the Open Telecom Cloud. I can show you later in the demo phase. And then you can create an access key and you get a secret key you can use here. So with these credentials, you don't use your password and your user ID inside Terraform, but this is linked to your user account. So if you look later in the cloud, you will see I have created this because they used this access key in the secret keys. So in the most cases, you will have an automation account, which is only used for the automation via Terraform, for example, and not your personal. Next one, you want to define, for example, an instance. Now, as I said before, in this case, I want to reuse the subnet, which also already defined. So I say it's a data resource, and I said, and this is the resource type. You will see something, I call it subnet default. This is the internal name of Terraform, and it should be named subnet default. So if Terraform or OpenTofu find this line, he will go search for all subnets and must find a name, one named subnet default. And if this is found, he will fill this variable name with the ID of the subnet. And this means you can later use this in the resource type for the instance. You see, network UUID, I use data, it's a data, Open Telecom Cloud, VPC subnet version 1, subnet default, and the ID from this, and the ID is the UUID of the subnet. Then you need a name. This will also be the name you will see in the portal of the Open Telecom Cloud. You say in which availability zone you want to have it. We have 3 in each location, so I chose the third one. An image name, I use a simple CentOS stream image. The flavor, so the size of the environment, I use this one. Key pair has to be defined previously. So I assume there will be a key pair available, which is called Terraform. And security groups, you can define a new one, or you simply say there is one called default, and you simply use it. So you have to find the main Terraform file. So he knows which publisher to take, how to log into the Open Telecom Cloud, and you said what you should do. And now, in most cases, you will do 4 steps. First step, Terraform init. This will configure the provider. It will look inside the directory or inside the internet and downloads the provider you have defined. Terraform plans, logs into the cloud, looks what is inside, and defines what has to be done. Third one, Terraform apply, starts the same like plan, and then asks you, should I do this? And if you say yes, he will start to deploy, for example, the instance you have shown previously. Last but not least, Terraform destroy. Destroy everything we had created previously. And what we have created previously is written in a file called Terraform TFWAS. So this is, for example, in your own directory you're currently working on. If you do a demo like I do it here, in normal things, you will use Git runner for this. And the Git runner has a shared Terraform TFWAS file so that you know what all your Terraform instances have created. In else case, you will have lots of instances. Nobody knows where they come from. Okay, so this is the second part. So let's first try the first demo. So if I log in to this account, I like to show you, as I said, if you go to the credentials, you see you have the access keys, and there you can simply create access keys, and there you will get the data you need to write down to the configuration of the Terraform. If you see, as you see, we don't currently have no Elastic Cloud Server, so we go to our command line, and I write down Terraform init. If everything works fine, he will find the Open Telecom Cloud provider. As you see, Terraform is arised. So we continue with, in this case, I use Tofu. As I said, they are equal up to one specific version. Tofu plan. Now we will log into the cloud, and he said, okay, I have seen, I will create something, and I will create a resource, Open Telecom Cloud Compute Instance version 2, with this name and this parameters. And if you simply say, yes, I want to see this, then he will start to create. So in this case, he will log in and will create the instances we have just defined. This will take some seconds, I think, well, in the maximum 1 minute. If you look here, you see this is the name, and he just started to create it, and it's running. So he said, apply completed. I added 1 resource, 0 changed, and 0 destroyed. And now we can destroy it again. And if you see Terraform destroy, it will look like very similar like your plan. But with this case, we have a minus sign, which means he will destroy it. So in this case, he will destroy, and he will destroy our instance you have just created, and he will also destroy the block device which has been added to the device. So if you define, for example, a complete environment with lots of instances, with networks, with security groups, and so on, you don't have to do this in the portal step by step and reverse your actions step by step. If you want to destroy it, you can deploy it in 1 step if you simply deploy it with Terraform. Or, and this is the next step, you want to deploy a cloud container engine. So the cloud container engine is the Kubernetes of the Open Telecom Cloud, and it's a standard Kubernetes. Currently, it's based on the version 1.30. And the big advantage of the cloud container engine is that you can reuse everything else which is in the Open Telecom Cloud. For example, you need some kind of object storage. You can use the object storage of the Open Telecom Cloud. You will create a load balancer. You can use the load balancer of the Open Telecom Cloud. So it's highly integrated in the Open Telecom Cloud, and it uses also the Open Telecom Cloud. For example, the masters instances of the central CCE, but the workers are instances you will see in your list. And so you will see the instances also in the list of your virtual machines. To define a cloud container engine with Terraform, you have to create it. But for this, some very nice colleagues have created templates. So with this, if you follow this link, you will get to a Git repository, and there you will find some examples how to create very, very fancy project within Open Telecom Cloud. And the demo I will show you in a few seconds is based on this module, Terraform Open Telecom Cloud CCE. So in this case, they created a CCE with Terraform. So this is from their example. You see we have a cluster Terraform file. You see we will create a private key because we need these keys also inside the Kubernetes. Then you create an extended IP, so external IP. So this is IP address you can access from the internet. A random ID, the key name, as I said previously. You get some storage encryption enabled. And interesting one is this is a cluster. So you see lots of variable names you have to fill for this variable type, for this resource type to create the cluster. And you don't only need a cluster, you need also a worker node. And this is done by a node pool. And this is also defined simple with Terraform. And as you see, that's all. You only have a very few numbers of resources, and these resources will be created by Terraform. Variable names are lots of them, but you have to fill only a few of them. Cluster VPC ID, virtual private cloud, this is mandatory. Also the subnet you have to create in privacy. So you have to give it a name. You have to say in which availability zones you have to want to create it. We have up to 3. I only choose 2 in this example. You say how many nodes you want to have per availability zone. In this case, I only say 1, but you could also say I want to have 2 or 3 in each availability zone. The node flavor, I choose a very small one, for a demo purpose. If you want to have high availability or not, this means how many instances you want to have for the master. Normally, you should have 3. This is also our default. If you say true here, I choose false because I only want to have a demo here. The cluster version currently in CCE supports version 1.29 and 1.30. And of course, you can tune the storage type. If you want to have high performance, you can choose SSD, and you can also choose more storage if you need more storage inside your cluster. And of course, you can fine tune all the variables you find here in this file. Let's go to the demo. And again, we start with Terraform init. Everything is fine. And then we will simply do Terraform. I will use apply in the first because it will check also, and because of time. And now you see he will create lots of resources. Interesting one, he will create the cluster and he will create the node pool. I say yes, and now he starts to create everything. So he starts creating a private key and the cluster key pair, and then he will start to create the cluster itself. There he started. And as you see, this is the output you will also get in the central log instance if you're using the Git runner for this one. And you can check inside if everything has been fine. And also you can put outputs inside your Terraform where you can put also the credentials and the instance name. So he just started to create the cluster. And if you now go inside our portal, you can go here to Containers Cloud Container Engine, and you will see he just started to create our Terraform CCE. We need to take some time. We have to wait. Are there some questions regarding the demo so far?
Do we have anything already in the chat? I haven't checked recently. Let me just see.
Because this is
asked if you can put the URL in the chat.
You mean from this one?
Like 5 minutes ago.
For the templates, yeah, that may come in handy.
Yeah.
So, but I may have a question while you edit, and you also use the OTC console now and then. What is your personal recommendation on working on the console and Terraform at the same time or on the same setup? Because if you change something that was originally created by some Terraform script, then this can lead to some kind of inconsistencies, right?
Right. Good question. Normally, you can use tagging inside the Open Telecom Cloud. So you can and should tag each resource you create. And I tag all my resources with a special tag where I know this is created by an automation. So for example, created by Terraform and so on. And then you see inside on the portal that this has been created by some automation in behind. And I recommend that you do this for all your resources. You will see later if the nodes have been added, they have created, will get a tag that you see these are nodes linked against a CCE. So that you know, I don't know this instance type, simply drop it. So use tagging for this to describe that they are created in the background by Terraform, or you use different projects. So you have a project where you can create something, and you have projects where only automation can create resources. So these are some remarks that you can do inside the Open Telecom Cloud.
Okay. And I see that Balash has also asked a question which is, well, at least indirectly connected to that. What about changing some parameters? Is it just destroy and recreate it, or what would you recommend here?
If you look inside the documentation of this provider, you see for each parameter name, what is the consequence of changing this? For example, if you change the flavor, this will mean he will destroy and recreate it. If you only, for example, add something, he will simply add it. Or, for example, change the name may result in a creation, for example, for instance, because the host name is divided from this name. But for example, if you rename a CCE, he will simply rename it. So it depends on the resource type and of the parameter name if he will recreate it. So simply do a delete and recreate, or if you simply execute this change.
And this is something that you look up in the system documentation.
In the documentation of the publisher, and there it's described what it means to change any value for these parameters, and there you see what will be the outcome. But for example, if you change something and have resources which combined with this, he will also change in the correct manner. So if you need to recreate some other resources after you create this resource, for example, install something on the operating system, he will also redo this because he knows how they are dependent. So as you see, he has created the CCE cluster, and he just started to create the node pool. So where's the refresh button? There's the refresh button. Now we can look inside, and at the bottom you see these are the master instances. So as I said, I don't want to have a high availability now, so I only get one master, and this is running in UUDE02. I defined two nodes, two node groups. He created one for DE01 and DE02. You can define them scaling. So you can define scaling rules when you should add more workers or remove workers. And he's currently scaling up to the desired node count of 1. And as I said before, if you look inside the Elastic Cloud Server, you see they are running. So he still has created them. And you see in the tags that you have given it a tag which defines this is used by CCE cluster with the ID and the UUID of the CCE cluster. So with the tags you see, okay, this is used by these resources. And so I recommend to use tagging in every resource you create with Terraform, which support tagging, and this is most of the resources. So he has completed. He has created 10 resources, 0 change, 0 destroyed, and now we have a running Kubernetes cluster. So we can, if we go inside the cluster, we can now download the kubectl and use this with an external IP and connect to this cluster. But we can also define the workload here. I've prepared some YAML code. So this is a simple Nginx, which only listens on port 80. And if this now is running, it's running. We can define simple a service on top of it. And on top of it, we define an ingress with a load balancer. And after this is created, we have an external IP. And if everything works fine, I should see the default side of Nginx. So it works. And as I said, because this is linked between inside the Open Telecom Cloud, if I now go to the network, to the Elastic Load Balancing, you see he has defined a load balancer inside the Open Telecom Cloud. We may discuss about the name, but it's a UUID. So in this case, if you see something with this crazy name, but it's not with CCE, you know this is coming and defined from a CCE cluster. And you know, don't remove it because this belongs to a service inside CCE.
Yeah, well, it was pretty easy.
Yeah.
Thank you so much, Thorsten. I mean, the extension possibilities are probably infinite.
Yeah.
In number, but this is an important first step for many newly deployed cloud-native applications. So this is a very useful template to build upon. Thank you so much that you shared and explained it for us.
You're welcome.
So then I would give the audience the last opportunity to ask the expert here. So if you have any questions to Thorsten right now, this is your chance. I think I spilled my shots already in asking that. Maybe one final curious question. Is it effectively possible to read the status of some setup?
Yeah.
And do more or less exactly the opposite way and creating some Terraform templates from what is just there, what you maybe have created manually in the OTC?
Yeah, you have an import option, and with this import option, you simply fill the values inside your Terraform file with dummy values, and then you say import this resource type. And then he will go inside. For example, you only give the name of the instance and fill the rest with dummy values. And then he will go inside the cloud and searching for this instance with this name and prints out what he has found inside the cloud. And this then you can use this for your resources you want to create. So a very fast step, if you only know what is the resource name of the resource, and don't wants to check the parameters one by one, you simply create it with the portal, import it, and then you adapt your changes. So the other way around is possible. Terraform or OpenTofu import is the keyword for this.
Okay, great. Good. Then I'd like to thank you and lead over to our third presenter. That is Attila. He's architect at the ITS, and you're here to walk us through on how to manage some cloud storage, Attila. So I think this is especially useful if you are running some functions. Is that correct?
Yeah, for example, or you can use it on your own device. So
Okay.
you can.
So I'd say
everywhere.
this stage is yours, and let's refocus on the third and last part of our today's presentation here. Attila, the stage is yours.
Thank you. So I will speak about the object storage on OTC, and I will use Python to communicate it with the object storages. At the beginning of my speech, I will talk about how can we put anywhere the object storages. And after that, I will tell you why I use Python and not another languages. And the rest of the presentation are 3 demos. So I hope everything will work fine. We will see. So the OBS object storage is located on OpenTelecom Cloud and it's much similar with the AWS S3. There are some similarities and differences. For example, the API compatibility is the same. So the OTC OBS can use the RESTful APIs and can use the same commands and additional, for example, Python libraries to communicate it with the object storage. The operators are the same. So you can put, get, delete, and you can do multi-part upload, for example. So this is also a similarity between the two things. If we can see the concept of the storage, they are using the same elements of the object storages. So we can define buckets and we can put objects on them, and to set the permissions, access control list and bucket level policies are also available. If we use any other clouds, the storage class is the same. So if we are using something frequently, we will put on a standard storage, and we can set the access to infrequent or archive, and we can save money with that. And both OBS and OTC object storage is capable to hold a static web page. So if you want to save some money, you can do that also. So what are the differences? First of all, the regional question. So the OpenTelecom Cloud is available only in Europe. So it's located into the Deutsche Telekom data centers, and the AWS is global scaled. solution. It could be positive or negative. If we talk about the sovereignty, it's huge advantages compared with AWS. We had a talk about the Keystone. The authentication of the OBS buckets on OTC is the Keystone, but on AWS it's simple, the IAM. So we don't need any additional things for authentication. If we see the console and the API access, the OTC is based on OpenStack. So we are using this technology. And the AWS version is self-managed and delivered things. Regarding the lifecycle rules and event integration, we have some limited features. And compared with AWS, they have more possibilities and rich integration with additional services. So why I choose the Python to talk about OBS? I think if we see the popularity of the programming languages, year by year, it's located into the first three. And there are lots of examples how can we use it with the web development or data science, machine learning, automation, and games, for example. And because of the popularity, lots of people use it and lots of libraries available to get you want to do on Python. And I really like that almost all operating systems can handle the Python. So for example, Linux, Windows, you can deploy your code on any VM, or you can use this well as, for example, function graph for this. So my first demo is a very basic thing. I will show you how can you read, write, and create a directory with Python. So first of all, we are using the Boto3 and Botocore libraries to reach the OBS bucket. And as we can see, we need an access key and secret key to access the OBS server. I don't recommend that to store in the code. So if you accidentally upload it to any version control system, for example, GitHub, the others can access your security keys, and this is not secure. So I put these information into the environment variable. So we need operating system environment to read these keys. And after that, we will define the connection to the OTC. The first task is to download the file from the OBS bucket. And after that, it will write it for us, what is included. And you know, the object storage is not a real hard drive. So there is no directories on it. Only 5 file details is that if the file is located into directory, and the browser or the console can handle that, how it's visible on the system. So the second thing is to create only a directory, and after that upload the upload file to this directory. And because of we don't need to use create directories, I would like to show you can do the file upload without creating any directory. So after the upload, this directory will be only details of the file. So I'm on a console, and that was the previous status. And we download this file, and the file contains these 3 lines. And we created a testing folder, upload the file to the testing folder, and the third one is we are creating directory and the file at the same time. So if I push refresh, you can see these files, and the upload file is into the directories. So this was the simple example. How can we read and write things? I prepared the more complicated thing. So we are testing big data on OTC, and we needed sample data to show how the DLI is working. And I need some automation to create a huge amount of information into OTC. So I created a script which is generating solar panel data and upload it to the OBS bucket. And later on, we can use this storage in DLI and use the data on it. So this script will be a little bit complicated, but almost similar. So we need both of three. We need the OS to read the credentials, and we need some random data, which is probably the solar panel can do. And as an IoT device, it will write the information to the OBS bucket. I was interested in how much time needed for the script itself. So at the beginning, we are configured access to the OBS, and using the pointer, this file is containing the year and months related information. And after that, the script will generate monthly data. So it will create tons of files which contains the actual power data from the solar panel. And if we have the file, it will instantly upload to the OBS bucket. And at the end, there will be some statistic information, how much time needed to generate these files. So I'm going to this directory and run the script. The script will create tons of files. As you can see, it's appearing in the temp directory, and it contains the date information, time information, and how much kilowatt generated by the solar panel itself. And parallelly, if we refresh the bucket, it will be stored here. And this will takes time. If you can see, we are at the third or fourth date of the month, so it takes about 4 minutes. I left it here. And to save time, I would like to ask you to prepare for the third demonstration. The third demonstration will be a static website on OBS bucket, and I plan to create this website together with you. So here is the vote, and I would like to ask you to help me to clarify what details will be on the static website. This vote contains 3 questions. The first question is about the web page background. The second will be a shape, which will be visible on the website. And the third question is some fill-in color, which will be filled in into the shape. Let's run this while we're waiting for the file creation. If you have any question during the time, you can also raise your hand or write it on the chat.
I see there's a question in the chat asked. So Fanny asks, can we directly use these Python scripts in function graph?
Almost similar question that you asked at the beginning. So on function graph, you can choose several programming languages. One of them is Python. So without any change, you can use these script function graph. The only hard part is the imported modules. So if it is not on the function graph, you have to create your own Python modules and upload it next to your script. And after that, everything works as we used on your computer.
And you did that for the Boto free packages. I think there was some other package that you used.
By default, the OTC contains about 3 or 5 packages, and the additionals need to be uploaded. For example, PyTorch is also available on function graph. If you need some image modification or you need this AWS CLI, you have to create your own packages.
Are there some predefined examples, or is there some community that you could recommend for newcomers to this field, and where should they look for support? Or is it better to ask your personal wingman AI for questions like that? What is your personal recommendation on that?
Regarding OTC, we have a community portal, and you can take any question and you can reach additional articles regarding different topics. And if you need more information about OTC, you can use that community webpage.
Okay, yeah, that's indeed a very good proposal. So there are lots of other users in similar situations in there. So getting in touch and starting the conversation is always a good idea. So I guess some numbers have filed in.
Yeah, my script is still running, but it will be the last day of the month, and it generated more than 4,000 files and uploaded to the OBS bucket more than 6 minutes. So I always talking about automation, so you can reduce human error and you can speed up any process with the automation. And by the way, while these files are generated, we have a chance to grab a coffee in 6 minutes. Okay, so let's see the third demo. It seems green will be the background of the web page, and there will be a circle, and the magenta or yellow will be the shape color. I like the code smarter, not harder title of these things, and I thought that I will create a website on OBS, which will be a static website, and we will need as OBS buckets where the website function is available, and we need an index HTML, and I would like to show you more time needed to do the poll than create the web page itself. So I'm using GitHub Copilot code, and I will ask him to create the web page itself. I'm checking the magenta will be the shape color, which is circle, and green will be the background. The title will be the OpenStack Europe. I'm checking the background is green.
Pretty sure we are going to win some art prize for the most spectacular design.
Let's see. So it generates the HTML code without us. So let's check. Here it is. And we need to upload this into OTC. I created a bucket called OpenStack Meetup, and I'm simple upload it. After that, we can reach the web page on this link.
So this DNS magic is made automatically by the OTC.
Yeah, there are advantages and disadvantages. The disadvantage is that it is only HTTP, not HTTPS. So if you need that, you need some API gateway or something which is in front of the OBS bucket. It can handle the SSL certificate. So we did this website together. Thank you for participating in it. That was the third demo.
So
we are completed on the presentation.
We have directly a follow-up question I just see. So Yeshwant asked, may I know where the DNS name can be configured?
I don't know by heart. We have to check, but I think this is internal OTC property. And if you want to use your own domain, it could be possible. And the additional feature is the redirection. So if somebody is reaching this web page, it could be automatically redirected to somewhere else.
Okay, right. Are there any additional questions? Yeah, okay. And the moment we have everything. So last chance for direct questions. So in this case, please raise your hand so that our invisible helpers on the back end can enable you to speak. The the questions mainly addressed. So thank you very much as well. With that, we are about to conclude today's session. Let me just see. Is here something else? Yeah, I guess it's time to send huge thanks to our speakers, to all of you for joining, for asking questions, and for just being part of this great community. If you like what you saw today here in the call, don't forget to share your experience of the events with colleagues, with friends. Join our community at the OpenStack Europe meetup group just to stay in the loop. So then we can send you updates for upcoming events. I think the next, it's not completely scheduled right now, but one of the next sessions will be again face-to-face session, maybe in Munich. That's at least the current working plan. See you, of course, at any of the OpenStack events, for example, at Open Infra Summit Europe, which takes place in October in Paris. By the way, check out if you want to be a presenter either there or here. Please reach out anytime. We are always happy to receive new proposals. So for papers, I just got some information from the colleagues at Open Infra directly. is open for another 4 weeks, I think, until early June, I think. And well, after a few days, you can just check our YouTube channels with the Clouders Club, which is accessible at YouTube directly with @Clouders Club. With that all said, I think we are done for today. Thanks again for everybody who tuned in, and hope to see you again at the next time on our channel here. And don't forget, don't code hard, just smarter. With that, goodbye.